Okay, so before we actually go up the ladder and start looking at things on the second floor, we're going to talk about the configurations of the different products. This is 2.5 self-furring lath. Now, in the camera it's going to be hard to see, but there's a dimple every so many inches offset in that row, so it'll be here and here on the next row, so many inches apart and 1/4 inch deep. That's to hold the lath away from the wall 1/4 inch so that when you plaster it, this orientation.
Set it down, you can see the dimples on the other one.
Yeah.
With it setting down.
Laying flat.
Laying flat.
You see the dimples.
Can you see the dimples on that? Yeah. Can you see that?
Yep.
Yeah.
All right, now this is 3/4 lath, so this is a heavier lath, but it's easier to see them than that too, so. Okay. And those are required in the manufacturing standard that they hold the lath away from the wall 1/4 inch. All right, and so these have been traveling around in my samples truck for years, so they're a little flat. But so anyway, you have this lath, and when you're plastering, you're going to take your trowel and you hit the wall and you come up into the face of this and up and over and then back. Now that's the reason I'm pointing that out is one of the first things we're going to look at is on the wall yesterday when we were here. You could see that part of the wall, and you can see it somewhat today, is real shiny and part of it's dull. We thought the lath was hung upside down on one side of that. That's not the case, and I'll explain that in a little bit. But so we wanted to see you have a self-furring lath. Now, you can use flat lath, but if you use flat lath, you have to fur it away from the wall 1/4 inch, which requires you to go put some sort of furring strip up there, which nobody wants to do. Now they do make out west, you'll see these, they make a furring nail that will fur it away, but I've never seen those east of the Mississippi, so I just don't see it much here. So, but it has to be furred from the wall, that's the key. Next we're going to talk about control joints. This is a control joint. There's a difference between a control joint and an expansion joint. By definition, a control joint is an M shape, one piece, and it's designed to accordion like this to accommodate thermal expansion and contraction in the green plaster when it first goes up. Once it's cured, this is not going to do a whole lot. It's not designed to accommodate movement in the wall in and out or movement in the wall this way. It's designed to accommodate movement in the plaster due to thermal expansion and contraction. Okay, so it works best when it's green. These are required by the standards. They are the bane of everybody's existence, and they create a lot of leak points and this, that, and the other, but they are required, and there are certain spacings that are required. They are also required to be tied to the lath. Now, the standard doesn't require that they're wire tied, it only requires that they're tied. So some folks use a plastic zip strip. If you're going to do that, a zip tie, you need to use a 75-pound tensile shear zip tie. They're easy to find, and use those. Because you're going to have one every 7 inches, and you got that many of them at that weight, that tensile strength, they're going to be fine for that. So when this goes up, there's two ways to do it. One is you always must have the flange to the wire so that it's expansion to expansion. Okay, like that. This is wrong. Okay, that will leak. That's not sealed at the edge. Water will get behind that paper. Now it's on the primary drainage plane, and you're going to cause water to get back there. It's probably not going to drain out the bottom unless you have a drainage space, and it's going to eventually get through there and cause degradation of the wood substrate. So remember, it has to go like this. Then this, you always, I'm putting that tight, but really you should hold it back 1/4 inch or so for the same reason we talked about cutting back the lath around the penetrations, so that you get plaster in here to protect the edge ends here that have been cut. All right, so if you hold it back 1/4 inch or so, and then tie it with either a zip strip or wire or whatever you want to do. If you use wire, it has to be 18 gauge galvanized wire. All right, all right.
Can we talk about, now, Mike? Can we talk about a common problem that they'll go ahead and lath it and then stick this on top?
Okay. So that's where I was going. Okay. Good question. Okay. So now this is one configuration. This is another configuration. There's nothing wrong with doing this. You can do this, but you need to remember that if you do this, the weather-resistant barriers, both of them, must be continuous behind the joint. And the lath has to be cut behind the joint. You cannot use continuous lath. All right, that will defeats the purpose of having this. All right, so now you tie it here. Now the problem, there's an issue with doing this, and that is all your grounds, all the other grounds, your mid-wall weep screed and your foundation weep screeds and all that, they're 7/8 of an inch. If this is 7/8 of an inch and you put it on top of the lath, it's going to leave a nose sticking out like that. All right, and that creates a bug run.
So should this be trimmed back?
So if you're going to put the control joint on top, which some people do, then you need to make sure you lessen the depth of the ground here. Now, that becomes an issue when they go to measure the thickness of the stucco, because typically the way you do it is measure this.
Right.
The way that a lot of the supposed experts do it is go out and cut a hole in the middle of the field of the plaster, and then they say, well, it's not deep enough here, it's not thick enough here. Well, that tells them it's not thick enough exactly right where they drilled the hole, but it doesn't tell them anything else about that. What it's like 3 inches to the left or right, they don't know. So that's not a good way to do it, and that's not the way it should be done. But anyway, the point is, you need to plan this. This should be detailed in the specifications on how you want this done. I prefer to see them this way. If you do them this way, you've got to somehow hold this control joint up until you get the lath on it. Now, here's another issue. In this particular scenario here, and if you've got lath going over the top like that, this paper has to go behind, but this paper has to go over.
It's a double layer.
All right, so it's the same paper, so the only way to do that is to cut one of them, right? Now that ain't good, because that's creating another leak point. So the better way to do it is not to use this paperback lath, but to wrap the house with your primary drainage plane, wrap the house again with your secondary or bond break drainage plane, and then put the control joints in the lath on. Then that's not a worry anymore, because it's already taken care of. Wow. Okay, so this is the reason I like to see houses wrapped twice first, and then plain lath, plain self-furred lath put on top of that. We talked about self-furred and we talked about the dimples, but there are other ways to fur it. There's another type of lath, I don't have a sample of it, but there's one called V-groove lath. This is not high rib or flat rib lath. It's plain lath, looks just like this, except instead of having a dimple, every 6 inches up the longitudinally, every 6 inches, it has a V, a 1/4 inch deep V pressed into it. So it's a solid dimple, the shape of a V, all the way the length of it, every 6 inches. Well, that's really nice because it holds it away from the wall better than the dimple lath does, and it shows you where to put your fasteners. You're going to put, because the standard says not to exceed 7 inches. When it says 7 inches, simply because we know you're not doing it with a laser, it's something you're having to do by hand, so it's an eyeball thing. All right, so we gave you a little tolerance. The code actually says every 6 inches. Okay, so if you've got a V-groove every 6 inches, you know exactly where to put your fastener, right?
That's a good point.
Okay, so I like that lath better. I'm sorry, the one sample I have of it has been in there so long, it's flat lath now. All right, that's one thing. Now this is both good and bad. This is the intersection of a vertical control joint at a mid-wall weep screed. So this is a mid-wall weep screed. You'll notice it has a 3.5 inch solid flange. That's a nail hole, okay? And it has no lip on it so that it weeps. And then it offsets to 1/2 inch down here because this is going to go from the transition of wood frame, which requires 7/8 of an inch, to a direct applied stucco over block, which only has to be a 1/2 inch. So if you look at that profile, you'll see that the 7/8 down to a 1/2. Okay? Now, so they've got this coming down here. This one happens to have tape in it, so you don't get plaster stuck in that, and after you plaster it, you peel the tape off and you're good to go.
That's smart.
Okay? But there's two things that I would do differently here. One, this is the location. You see it's sealed here. This is the one location that you don't seal an intersection of accessories. Because if water gets behind this and it hits a weep screed, you want it to come out there. If you seal this, it's going to tower up until it goes behind that. All right, so you don't want it doing that. So this is wrong in the fact that it has sealant here. All right, the other thing is typically now they've done this for demonstration purposes, but really this should be butterflied, and actually this one should be butterflied, and this one should be butterflied so that they fit together and all in plane. Then you can use 7/8 and 7/8 and everything lines up. If you put one at 7/8 on top of another one that's 7/8, this one's going to stick out about a 1/16. Okay, so really they should be butterflied to fit together, but this does work and you can do it. Okay, in fact, if you use a 3/4 joint here, on 7/8 here, it'll work out.
Everything works but the sealing at the bottom.
Yeah, yeah, take out the sealing, right. Okay, those are the big points I wanted to make with that. So this is an example. This is actually a prototype, of a new plaster stop. And you'll see it has on the back, on the attachment flange, by the way, this is an attachment flange. This piece is the ground flange, it's how deep it is. This piece is the capture flange. It captures the plaster and holds it in place. If it turns down, it's a drip screed. Okay, all right, so, but you'll notice that this attachment flange has a double curve in it. That does two things. One, it stiffens the product up a lot more, because that's a complaint that that plasters have about plastic or PVC accessories, is that they bend too easily. It stiffens it up a lot. But they also do this, this is a proprietary thing, so I'm not going to say who. They're also doing this now on a control joint on this flange, and if you can imagine, having this ridge in the control joint will make that so much easier to tie to the lath. And so that's a nice innovation. I can't tell you what the cost differences are, but I'd expect there would be some, but it's a nice innovation. So, okay. So we're back to the wall we started on, but we're going to go upstairs now. So I wanted to get a global picture of this because there's something I want to point out here. If you notice, the lath to the left is very shiny, and the lath to the right is much more dull. So when we saw that, when we were here yesterday prepping for this, we noticed that and we thought immediately part of this lath is hung upside down because there's a right way and a wrong way to hang the lath. And so when you run your hand over it, and I'll go up here and show you this in a minute, but if you run your hand over the lath, it's like good whiskey. It should be smooth going down and rough coming back up. Now that sounds counterintuitive because you'd think you'd want the mud to slide into the cut, but that's not the way it works. When you remember, when your plasterer's got a hawk, which is that big square thing with a handle on it, you know, and a trowel, and he takes this mud off that hawk and he hits the wall and he comes up and over, up and back like that, up and over and back. And then he does it again, up and over and back. So in this particular case, correctly oriented lath has the rough side pointing down. So when you run your hand over it, you feel that. What it does is it pulls the mud off of the trowel and forces it behind the lath, encapsulating the steel. Encapsulation is not the same thing as embedment. It's required to be embedded, but in Florida, you really want it to be encapsulated because as long as it can't get moisture and air, it can't rust. So you need to understand that galvanization is a self-sacrificial coating that will give itself away over time if it's exposed. Once it's gone, you've got bare steel, and bare steel is going to rust if it's got moisture and air. And in Florida, it's going to have moisture and air. There's just no way around it. So, and then you also have, near the coast, salt air, and that's even worse. So you want to make sure you've got your lath hung right, that you're forcing it up in there behind it. Now, while I'm saying that, there's a tendency in the plastering trade today to use what they call a slicker. It's a piece of aluminum about 3 or 4 feet long, about 6 inches wide, and they go to a mortar board and they scoop up mortar like that, and they hit the wall and they come up with it. And then they go get some more and hit the wall and come up with it. Slickers will be prohibited in the next version of the standard that gets adopted by the code. And there's a reason for this, and we've been all over the country researching this, and the reason for it is you're not encapsulating or even fully embedding the lath behind it. 2 reasons. One, you've got pressure here and nothing in between and nothing on the ends, so it's not forcing the mud up in there behind it. And 2, they're only going one direction. So they're bringing it up, which leaves some voids that the trowel coming back fills. You don't get that with a slicker. So the next version of the standards will prohibit the use of slickers for the application of scratch and brown coats. After that, it doesn't make a whole lot of difference. The thing is, that's not what that tool was designed for. And to begin with, it's really called a derby or a rod. And what it's really for is plating out the brown coat. So the first coat of stucco goes on as a scratch coat. It goes on about 3/8 of an inch thick. You take a rake and you scratch it back. Bob, if you would, I've got a scarifying tool in my bucket of goodies over there. And you scratch it back horizontally, and then you put the brown coat on, and you bring the brown coat out about 3/8, and then you rod the surface off to plumb and level as best you can. Now, you are allowed a tolerance of 1/4 inch and 10 feet for tolerance because this is a hand-applied product that takes an artisan to do correctly. This is not something you just slap up there. And I defy anybody who's just never done this before to go out there and do it and make it look good. All right, so it takes a guy who's been doing this for a while, a journeyman or master plasterer, to do this and do it correctly. This is a scarifying tool. This is what you scratch with. Obviously this was still wrapped, but you can see it looks like a big rake. Now, I've seen this done successfully with just a cut piece of lath and using the lath to create it. It will work, but you've got to create, what you're doing is creating a mechanical key for the next coat to hang on. So it's always horizontally, because simply this, thank you, Bob. It's simply this. If you had to go hold yourself up in a doorway, would it be easier to try to hold your arms out like that and hold yourself up, or would it be easier to hang on the ledge? That's the intent of a scratch coat. You simply want to hang on it, and that's why you do that. A brush won't work. It doesn't create enough key. You need a mechanical scratch. That's the way to do it. I've seen other things work. I saw a guy do it with a cast iron garden rake one day, worked fine. But whatever will work that makes a definite groove, that's what you need to do. You also need to wait till the stuff is thumbprint hard before you start scratching it. If you do it too soon, then it will ravel and hang down, and that will create more problems. So you don't want to do that. So the standard allows you, the code and the standard both allow you to scratch and brown in the same day. Actually, it doesn't even prohibit finishing in the same day. The original plastering requirements were that you scratched, you waited 7 days, and you browned it, you waited 7 days, and you finished it. You know, that kind of thing. That actually is the best way to do it. And it's because it allows each one to shrink and do its thing before you put the next one on. But we've also found that if you put the brown coat directly onto the scratch coat while it's still damp, then the two coats tend to grow together and lock together monolithically better than they do otherwise. Okay, so there are advantages to both. I don't really have a problem with the double back if you don't do it too soon, but I would like to see people wait at least 3 days, if not a week, to put the finish coat on. I can't force that. I just think that's a best practice. Okay.
So Mike, I'm seeing 2 control joints on this wall here. Kind of tell us what's the code requirements on that for the standard?
Okay, according to the standards, control joints have to be spaced in there's 3 qualifications. One is an area not to exceed 144 square feet, or 12 by 12, or whatever, or not to exceed a length to width ratio of 2.5 to 1, or no longer than 18 feet in any one direction. So if you've got 18 feet long, you can go about 6 feet high before you get to that 144 square feet, okay? So it's like that, so you have to isolate them like that. They are not required in direct applied stucco, and they will not work on that block wall down there, which is why you don't see them continuing here, okay? They're not required, they don't work. If they use them, it's simply to provide a depth screed, so when they're trying to plumb it out, or for you know, if some architect thinks it's aesthetically pleasing, you might get that. But they're not required down there. Another question came up, and that's about attachment of the lath and how you do that. So the standard requires that the fasteners be placed not to exceed 7 inches vertically into the framing members, which is the stud. Sheathing, the wood sheathing, is not a framing member. Framing members are defined in the code and in the standard, and it specifically exempts or accepts sheathing from that definition. So it has to go into it. Now, it then goes on to further say, so you see you've got one here, and if you read the IMLA standards, the manufacturing standards, they'll tell you to put the staple in the dimple if possible, because you don't want to take away that furring capability, and everywhere you've got one, you're going to take away the furring capability. So you want to put them in the dimples if you can, which is one reason why I like this 3 and 3.5 inch spacing, because that way you're going to hit 6 or 7 inches going vertically, right? Now, it also says that staples in the field should be avoided. Staples between framing members should be avoided. It actually says shall be avoided. Now, the intent of that was not to say that you can't have a staple in there if you've got a bird mouth or you got a piece of lath that's poking out and pokes back through every time you. It's not to stop that. And so a staple or two here or there in the field does not hurt anything and is not prohibited by the standard. What the standard is trying to stop was in the old days we would have inspections and the inspectors would do this, and if they couldn't touch a staple, there weren't enough. And that's not right, because going that way they should only be every 16 inches apart. And your hand isn't 16 inches long. So that's the reason it was taking away the furring capability and causing the lath to rust because it couldn't get encapsulated. So we don't want you to do that. But if you have to have one to hold the lath down, or at a lap where you've got a bird mouth, which is just basically one of those things, and you need to hold it down so you can plaster it, so what? It's not going to hurt anything. So some folks say, well, it's a penetration through the WRB, and yes it is, but you've already got 20,000 of them and at every staple or every nail, so what's a few more? Nothing. Now, they're only in the sheathing, but the fact is that staple going into the sheathing, if water does go through that, the pressure created by the sheathing backs it up and stops it from going anymore. So this is really not a potential leak point like you'd think it would be. Now, if there were not any sheathing back there, then it would definitely be a problem. But so that's another thing. One of the reasons into the framing member is that it goes through the sheathing and into the stud. That creates solid back pressure as soon as it gets any water in it, and no more water can go through there. It just sheets over the top of that penetration. All right, so that's the reasoning for that. Now, there are some inspectors that will go and look, and if they find any shiners at all from the inside, they'll fail you on it or make you do something with it. You really don't need to do anything to it, just leave it alone. But if you want to bend it over to make it easier for the insulator to do his work, then fine. But don't go take them out, because then you got to seal the holes. Just leave them where they are. But if you have a few here and there, you should not fail a house over it. However, if you've got half a dozen of them in every space, then that's way too many, and that should be, all right? So what I'm saying is, now and then's okay. Okay?
Okay, Mike, so what we're doing now is we're going to come up to the window and this whole area right here with a control joint. Mike?
Right, yeah, so I wanted to answer your question about it's not really about the control joint, but this is a good example. So we said earlier that, you know, they are wire tied, but they're tied at about 12 inches. And the standard's going to require that they're tied not to exceed 7 inches on either side, okay? And so is that a real issue? So this would be an example of a technical violation of the code in that it exceeds 7 inches. However, I would not consider this a material violation of the code, simply because it's not going to cause any damage to any of the rest of the system. In other words, remember that it was only to hold this in place until the plaster sets. Once the plaster sets and keys out all together, it doesn't make any difference anyway. So I would not consider that a material violation. If I found a few that were that way, I'd probably let it go. If I found all of them were that way, I'd probably tell the guy to tighten up, because the next time I'm not going to let it go and handle it that way. Okay, so that's it for control joints. The first thing I noticed about this window is that they do have the window isolated from the plaster. You can see that there's a plaster stop or casing bead here. It has the backer rod already in it at the right depth and the right shape. The other thing they did really nicely here is this flange is cut on the attachment flange and on the capture flange and bent around that corner. So is the one at the top. These are done, you know, that's the best way to do it. That one thing that will do is help prevent these diagonal cracks that you get off of windows like that. It will help prevent that. But the other thing it does is it gives you a solid shelf and no place for water to get in at this cut. So that's a nice way to do that. You'll notice that the joint is here. So they've come down, around, and up, and then there's a joint on the other side for a stick of bead. That's a perfect installation for how those should be done. All right? And well, yes, and he did caulk his butt joints here, okay? Now, this is a flanged window, so it's got a nail flange back here. It's nailed into the sheathing. It's a surface mount or flush mount window, and what's going to happen is it's going to get plastered up to here. What we're running into a lot is we'll find a window up here that has what they call a face fin or a face flange on it, which is another flange that comes out like this. And what that does is it creates a U channel between the surface and the wall of about a ½ inch deep and the width of the window, whatever that happens to be. There is no way to force mud in there and plaster that and make it seal watertight. That face fin should not be there. Most aluminum extrusions are extruded so that there's a groove along there so that you can cut it and snap that face fin off. They will do that for you at the factory or at the distributor if you ask them to, and deliver it properly. So it should have a square-edged return to finish the Plaster 2. This one does. This is a good example of how a window should be installed. If I was going to do anything here that would to benefit this, sometimes if you take a 2 or 3 inch strip, wide strip of lath, 6 or 8 inches long, and come diagonally across the corner here, that's called a butterfly, and it reinforces the lath right here and can help eliminate this cut again, okay? This crack again, rather. They're not 100% efficient, but they can help. I've seen people do it with plastic lath, and that kind of thing works well too. Doesn't matter. But doing this and putting the window in a soft joint will eliminate most of that, and adding the butterfly should fix the issue for you. The other thing you could do is you could actually put a piece of lamina like EIFS tape in the brown coat here when you brown the wall, and that'll do it as well. Okay, is there anything else? The lath is cut. It's back, for the most part, it's back about 1/4 of an inch from the edge of the plaster stop. We talked about doing that to protect the lath. That's good. It's that way on the side here. Should be in good shape for this window.
Very good.
Okay, so here we have a roof returning to a vertical wall, and you can see they've got the plaster isolated from this, and that is a requirement. This is a real problem on a lot of houses. This one's better than most, and in the fact that they do have it isolated with casing beads and all of that. But really, a better way to do this is to hold this subfascia back a couple of inches from the surface of that OSB so they can plaster behind that right here. In other words, there's a piece of metal flashing on the top, an angle flashing that goes up there. It should continue over here and down below as well. If you look close, you'll see it's right there. So it is in there, but continue it down below as well. If you move this back out to here, they can plaster behind that, and it helps protect that corner. This is the kind of place that becomes a leak point and a damage area on most of the inspections we do after the fact. Water gets, if they don't isolate this and they're plastering right up against this drip edge, that kind of thing, it's going to separate and water will get behind that, and it causes rot along in here. All right, so that's a design issue that needs to be addressed. They're doing a better job of it here, but there are better ways to do it even yet, and we can help them with that. Then let's go back to control joints for a minute. We talked about embedding butt joints and joints of accessories and sealant. And I said that the one place that you don't do it is where an accessory dies at a weep screed. This is a mid-wall weep screed. And they've come back and sealed this up. So if water gets behind that joint, it's going to tower up here until it comes out. So this is the one place you don't want the sealant, is where an accessory dies at a weep screed.
And would you change that?
I'd
it out to the outside?
I would not do it now.
No, I just say, if you would have done it to begin with, you would have held it to the outside.
I would have had this detailed in the drawings, and it would have done it a little differently than this, yes.
Okay, but I'm asking about your expansion joint. Would you have moved it out to?
I'd have probably put the control joint here. Yeah. I'd have probably put it here.
Okay, that's what I was looking at.
In fact, it would be better here.
Right.
Because that's where the stress is going to be when it changes configuration.
I know why they put it there, because it lines with the upper wall there.
Yeah.
To keep that line keep straight. That's why they did that.
The aesthetic reason for doing that, but it would have been better service-wise from here, okay? I do see that the one case I've seen where they're a little long, they got the lath a little long, it's called burning the ground. The lath is actually sitting on the ground weep flange here, and that's a little long. If you burn that ground, you want that lath to be just a little bit, 1/4 inch shorter reaching that. But that's the only thing I see there. This will finish out nicely with a backer rod and sealant and prevent leaking here. This cannot be cut and bent around because they're two different pieces. So it's a plaster stop and a weep screed.